Now we are going to look at 7.7 probability density function. For a continuous random variable, the probability density function is defined by its probability density, which is consisting fx, where fx is more or equal to 0 for all values of x. Okay, look at this diagram. So a continuous random variable with probability density function must satisfy the following condition. First, fx must greater or equals to 0 for all values of x. Secondly, the integrations of fx for all values of x in the interval must be equal to 1. And the third condition is if you want to find the probability x between x1 and x2, you have to integrate fx from x1 to x2. Look at example 26. X is a random variable which represents the time taken for a teacher to mark a quiz in a minute with the probability density function as follows. Okay, so you have fx is equal to 0.2 minus 0.02x when x between 0 and 10, including 0, including 10. First question, show that fx is a probability density function. Second, find the probability that a teacher takes between 2 to 5 minutes to mark a quiz. So for the first question, we need to show that the integration of fx is equal to 1. So what we can do, we integrate our function, which is 0.2 minus 0.02x, and integrate from 0 to 10. So as you can see here, the integration, you will have 0.2x minus 0.02x squared over 2. Then what you do, you substitute 10 as shown here, and you substitute 0. And the answer is 1. Therefore, we can conclude that our fx is the probability density function for a continuous random variable x. Okay. Next, question B. The probability a teacher takes between 2 to 5 minutes to mark a quiz. So, to find the probability, we integrate the function from 2 minutes to 5 minutes as shown here. So, this is the function when you have integrate, and you substitute 5 in the integrated function. Then you substitute 2 to the integrated function. So you will have 0.75 minus 0.36, which is equal to 0.39. Okay, the last example I'm going to show is using example 27. The continuous random variable x has a probability density function as follows. As you can see here, there are two intervals. From 0 to 1, we have this function. From 1 to 3, we have this function. So if you need to sketch a graph, what you have to do, you just substitute a certain value of x inside the function. So for x equals to 0, the function is 4 over 11. For x equals to 1, you're going to have 2 over 11. For x equals to 3, you're going to have 6 over 11. And f equal to 2, you're going to have 4 over 11. So what you do next, you can plot this. Plot the points. So for 0 just now, we have 4 over 11. For 1, we have 2 over 11. For 2, we have 4 over 11. And 3 is 6 over 11. And you join the points. For second question, you need to show that whether this probability density function is a probability density function for continuous random variable. So what you need to do, you have to integrate both functions. From 0 to 1, you have this function. From 1 to 3, you have this function. And you integrate as usual. So you will have 2x minus x squared over 2 and substitute 0 to 1. And the second function, when you integrate x, you get x squared over 2 and you substitute 1 and 3. So as you can see in this slide, this is how you substitute the value of 1 and also 0. Over here, you substitute value of 3 and value of 1. So when you calculate this, you will get equal to 1. Right. So hence, fx is the probability density function for the continuous random variable. For question C, find the probability x between 0.5 to 2.5. In order to calculate the probability, you have to break it down into two intervals. First, the first function, you integrate from 0.5 to 1. And the second function, you integrate from 1 to 2.5. So this is the function when you have integrated. So you get 2x minus x squared over 2. And the second function, you have x squared over 2. Substitute the value of 1 and also the value of 0.5. And this one, you substitute the value of 2.5 and the value of 1. And calculate as usual. And the final answer is 0.591.